Hi everyone! In today's video, I will be going over the Unit 6 study guide. During this video, make sure you have a calculator handy. I'm going to be using it quite a bit. Okay, on the front here we have different types of statistics problems. Number 1, Andy has 5 shirts, 3 pairs of pants, and 6 pairs of socks. How many different outfits can Andy choose with a shirt, a pair of pants, and a pair of socks? So when they give you a bunch of numbers, a bunch of different categories, that is a big sign that you have an FCP problem, a fundamental counting principle problem. Remember, that's a problem where you just collect the numbers they give you and you just multiply them all together. So we have 5 times 3 times 6. Make sure you have all of the numbers. The biggest mistake I see on these problems is students just leaving a number or two behind in the directions. So that's why I circle them, just so I don't forget anything. Okay, 5 times 3 times 6, that's going to be 90. Number 2, Monique is having a 5-course dinner in the dining room on a cruise. The menu consists of 2 appetizers, 3 soups, 2 salads, 4 entrees, and 3 desserts. How many different meals can be configured if she chooses one of each course? So again, you have different categories here. So once again, we have an FCP problem. Some students may try to do a combination or permutation here. Remember, when you have separate numbers, do not add them together. If you were to try combination or permutation here, that would be how you would do it, and that is not correct at all. So if they're separate, keep them separate and multiply the numbers together. So we have 2 times 3 times 2 times 4 times 3. And make sure you don't include the 5 in that as well. That's there to kind of trip you up. Some students will see that 5 and immediately multiply it in. This is why reading the directions are important. So if you multiply that together, you will get 144. From a club of 20 students, in how many ways can a group of 3 members be selected? So you have 20 students to choose from, and then this wording here, group of 3 members be selected. This means you have a permutation or a combination problem. You have a group of 20, that means N is 20. And then R, so remember this is your total, N is your total, and then R is your number chosen. We're picking 3 people. Now the question is, does order matter? If this is something you struggle with, reminder, you can come up with an example and play with it. So I'm going to do that right here. So we're picking 3 students. So just 3 names. It could be any name you want. You can make this as complicated or as simple as possible. I'm going to go with very short names. So let's say my 3 names are Sam, Linda, and James. So those are my 3 names. Those are the 3 students I selected. Now remember, the question to ask yourself, if I switch around the order of any of these names in my 3 that I've chosen here, so let's say I swap Sam and Linda. If I swap their places, does this make a difference in what I chose? No. I still have the same 3 people in this group here. They're not assigned any specific responsibility or position. They're the same 3 people. So, order does not matter. So this is a combination. So, what I'm going to do to get my answer is 20C3 and then I'll use my calculator to get my answer. So we have 20. Remember, type in the first number first, and then you go under probability, arrow over, NCR, and then 3. 1,140 combinations is our answer. Okay, number 4. The company Siesta has 10 members on its board of directors. In how many different ways can it elect a president, vice president, secretary, and treasurer? Now, this is a dead giveaway of a specific type permutation or combination. But if you don't see it, I'm going to do one quick example, just like I did on number 3, just to show the difference. Okay, so for this problem, there are 10 members to choose from. So that means our N is 10. And then they're electing 1, 2, 3, 4 positions. Make sure you keep count on that. I have students who will miscount that all the time. Okay, again, you can have your example. And I'll pick new names. Okay. Let's do Angie, Aaron, Cameron, and Dave. 4 names, 4 random names. Okay. Now, if I put them in that order, that means Angie is president, because we have to assign them by their positions. Aaron is VP. Cameron is the secretary. And then Dave is the treasurer. So again, I take my order that I've chosen, my example, and then I ask myself, if I change the order, so let's say I switch Angie with Cameron. That means Cameron is now the president and Angie is now the secretary. So if you ask me, does order matter? Absolutely. These people are totally going to care if they get put in a different position. That's different responsibilities. That's a completely different title. And in some cases, that can even affect your pay. So this is important. Order absolutely matters here. So remember, when you have positions involved, titles, that's a dead giveaway that this is a permutation problem. So remember, you don't have to come up with your own example, but if you can't tell whether order matters, this is a nice way to do it. Since we now know this is a permutation, this is 10p4. Calculator. 10, probability button, click on the P, and then 4. 5,040 permutations. Number 5, the ski club with 10 members is to elect 3 officers, a captain, co-captain, and secretary. How many ways can those offices be filled? Once again, we are choosing 3 people and they're going to have titles. So again, it's just like number 4. Order absolutely matters here. So different. And you could call these positions or titles. That means, again, you have a permutation. That's how you can tell. These are some of the more obvious examples of permutation. All right, we know that N is 10. That's how many people we have to choose from. And then they are choosing 3. Captain, co-captain, secretary, 3 officers. So this one is N, 10P3. Now, this is almost exactly the same problem, so I'm just going to arrow up and change what I had here. So now I have 10p3 instead of 10p4, and I now have 720. One more. There are 12 people waiting for a flight to Hawaii, but only 6 seats are available on the plane. How many different ways can the 6 people be selected? Now, you want to read this one carefully because you could probably make an argument for either one, but in my opinion, there is still an obvious choice here. So, you have 12 people and you're choosing 6 of them. Now, at first, the way it's worded here, it says 6 seats are available. That might make you think permutation. But again, I could come up with a list of names. In this case, I would come up with 6 names instead of 3, like I did in number 3, the problem directly above. But order does not matter here. If I put those 6 people in a different order, because we're not assigning them to a seat necessarily. We're just saying, hey, you can go on the plane versus someone who can't go on the plane. So if I put that group of 6 in a different order, again, I can come up with a list of 6 names and put them in a different order. That will not change a thing. They will still be going on the plane, and the other 6 will still not be going on the plane. So there's no change there. If we were assigning these people to a specific seat, then we can make an argument for permutation here. Since that's not what we're doing, we're just saying, hey, you 6 are going on the plane. It's a combination. So I'll add an explanation here. Just choosing who is / is not going on the plane. Order does not matter. So, this is a combination. So that means we have 12 choose 6. And that gives me 924. Okay. Number 7. The state of Maine has 7 characters on their license plates. The first 4 characters must be capital letters and the last 3 must be digits. I'm going to pause here. Let's set up our template. So the first 4 must be letters. We got letter, 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 letter. And then the last 3 are digits, otherwise known as numbers. Now you have to pay very close attention to the requirements here. Letters I, O, Q, S, and Z are not used in the Maine license plate. And each digit or letter may be used more than once. How many different license plates are possible in the state of Maine? This is a problem you're going to want to read multiple times as you're doing the problem. Make sure you include every detail. So first off, letters I, O, Q, S, and Z are not used. So that's going to affect the numbers that I put in these blanks here. So we have I, O, Q, S, and Z. That's 5 letters. So since there's 26 letters in the alphabet and I am taking 5 of them out that I'm not allowed to use, that leaves me 21 letters to choose from. So we've got that. And then there's no restrictions on the numbers. It just says digits. We use digits. Since it says that we use digits and there's no clarification, we assume we're allowed to use numbers 0 through 9, which remember is 10 letters. 1 through 9 is 9 plus 0 is 10. So, this would be what our L is, and then this would be what our N is. Another key detail, you cannot forget it. Can't read over it. Each digit or letter may be used more than once, meaning repeats are allowed. That's going to change your numbers. That's going to change your whole problem. You have to pay attention to this. Since repeats are allowed, I don't have to take one away every time I move to the next space. So my letters, I've got 21 to choose from. First space, I've got 21 to choose from. Second space, I'm allowed to repeat, so I still have 21 to choose from. So all 4 of these will be 21. Numbers, I've got 10 to choose from. And then again, repeats are allowed, so I still have 10 to choose from. 10 in all 3 blanks as well. So here are my numbers. Last thing you do, and yes, it's going to be a large number, you multiply all of that together. We'll definitely need a calculator for that. And it's going to be a big number. Okay. So multiply 21 4 times. And then 10 3 times. Okay. That looks to be 194,481,000. Make sure I got all my digits correct. Yep. 194,481,000. That is how many license plates you can make. Number 8. Each position on the lock below has digits 0 through 9. So again, you have 10 digits. Digits 0 through 9. How many combinations can the lock have if no digit can be used more than once? Repeats not allowed. That changes things. So we have a 3-digit combination lock here. So 1, 2, 3. Got numbers in here. We're still using digits 0 through 9, so we have 10 of them to use. Now, since repeats are not allowed, my numbers are going to go down from space to space. First space gets first choice of the digits, so there's all 10 to choose from. Next space, I have taken one choice out. It's whatever I put in the first space. So now there's 9 left. And then one more time the second space, I now have 8 left because I can't reuse the same digit from the spaces 1 or 2. So 10 times 9 times 8. This will give you 720. So make sure you take your time and really work with these problems. It's very tempting to go ahead and just treat these as combination or permutation. I will tell you some of them can be solved that way, but I'm not going to go into that much detail. Sit down and think about it like I did here. That's how you're going to get the problem right. Okay, these next two are very simple compared to what I just did. We're literally telling you what to do. You just have to type it into your calculator correctly. So, we have 12, C10, 66. That's it. Okay. They're the same problem, just one's a permutation, one's a combination. I'm going to clear this out before I make a mistake. 12, P10. Big difference there. Okay. Let me gather my digits here. That is 239,500,800. Let me just make sure I got all that down correct. Yes. If that's something you struggle with, just write down all the numbers. Don't worry about the commas, but I like to be precise here. All right, next page. So on the front, those were stats problems, your FCP problems, your combination permutation problems. Now we're going to get into probability. Number 10, what is the probability of flipping heads on a coin and rolling a 1 on a 6-sided number cube? Unfortunately, I saw it a lot. A lot of students did still kind of treat this as combination or permutation. When you see probability, when you see that phrase, you will have a fraction. Just know. What is probability? You will have fractions. That's a good start. Now pay attention to what your probabilities are. We've got probability of flipping heads on a coin. So that's probability of heads. A coin has 2 sides, and one of those is heads. So you have a 50-50 shot here, 1/2. And rolling a 1 on a 6-sided number cube. Basic die. So you have probability of rolling a 1 on a 6-sided cube. So you've got 6 sides to choose from. One of them has a 1 on it. So those are my 2 probabilities. Now, carefully multiply straight across. Don't add. It's a very common mistake to make. 1 times 1 is 1. 2 times 6 is 12. And you can't reduce that, so that's our answer. Number 11. What is the probability? Once again, see that phrase, you know you're going to have fractions. Just a given. Of rolling a 4. So probability of a 4. And then an odd number on a 6-sided number cube. Probability of odd. Okay, we're still working with the same 6-sided cube. So these are both going to be out of 6. Now, again, on a 6-sided cube, only one of those numbers is a 4. So this is still 1/6. Now, remember, the cube is numbered 1 through 6. So our odd numbers are 1, 3, and 5. 1, 3, and 5. Those are my 3 options. So I have 3 odd numbers on this cube. 3 odd, 3 even. So I'm going to multiply those 2 together. Once again, make sure you multiply straight across. 1 times 3 is 3. 6 times 6 is 36. Now, reminder on the test, you do not have to reduce, but if you want to, you may. And I showed you how to reduce in the calculator, so let me refresh your memory on that trick. This button right here, the A, B/C, this is used to reduce fractions. So we have 3, and then instead of typing the division symbol for your fraction, you'll type in this. It looks like a bracket. 36, hit equals. And the reduced fraction is 1/12. If you just kept it at 3/36, that is still correct. Okay, number 12. Suppose you draw marbles from this jar without replacement. Without replacement, pay attention to that. Give each probability as a reduced fraction. Again, it says that in directions, but on the test, if you don't do it, you're still going to get the point, as long as your fraction is correct. Okay. I'm going to add the note here, marbles not replaced. And I want to clarify, and I'm going to say this again when I actually do the problems, because I've had questions on that several times. When we move from one problem to the next, we're assuming that number restarts. So it's not a domino effect where I take out these 2 marbles here, and then I've only got 10 or however many left. I've got those 2 still taken out when I go to problem B. I put them back. They restart at each problem. But in the same problem, that's I take one out, I don't put it back kind of thing. Okay. The most important detail, and often you will forget to do this until you try the problem, is you need to figure out how many marbles are in the jar and how many of each type do I have. That's going to make doing the math much easier. So, we have, and this is when you might want to look at the key before you get started, but the dark colored ones, those are the black marbles. There's 2 of them. The gray marbles, so the lightly shaded in, there's 3 of those. The striped marble, there's only 1. So what's left, just the plain white ones, there's 4 of those. And then the total, you just add those up. 2 plus 3, that's 5, and 1 is 6, and 4 is 10. So, you have a total of 10 marbles in the jar. So, this is going to go much faster now that I have these numbers written out over here. So remember, this is the order that you're drawing the marbles from the jar. So, you do the probability of just B, and then the probability of W, and you're going to multiply those together, per usual. So, first we are picking from the whole jar, which is 10 marbles, and we're going to pull out a black one. There's 2 of them. Times, when I go to pick the next marble, remember I have taken a black one out, so I now have 9 marbles left. And of those 9, 4 of them are white. Remember, multiply. 2 times 4 is 8. 9 times 10 is 90. And then I'm not going to show it, but if you choose to simplify it on your calculator, it will come out to 4 over 45. That's optional. And again, fraction, or the directions say reduced fraction, so technically this is the right answer, but we won't dock you for that on a test. Okay, problem B. Probability of S and then G, start to say green, that's gray. Now remember, we are on a new problem, so the numbers reset. So I still have 10 marbles I'm choosing from. I don't have 8 now, we're not doing that. New problem, reset, restart. I have 10 marbles again, and only 1 of them is striped. Times probability of getting a gray marble. I've taken the striped marble out, so I have 9 left, 9 marbles left, and 3 of them are gray. Once again, multiply straight across, and you get 3 over 90. And then, since we're supposed to simplify, you get 1 over 30. All right, C. Probability of gray first. We have restarted our numbers, so we're back up to 10 marbles, and 3 of them are gray. Probability of getting another gray. We've taken a gray marble out, so we have 9 marbles left. On top of that, since I'm repeating the color, I now have 2 of those grays left, because I'm assuming I picked 1 out the first time. So we got 2 left, 9 marbles remaining. And now the B, the black marble. I now have 8 marbles left because I've chosen 2 of them. Both of them are gray. And I still have 2 black marbles in the jar. I haven't picked those out yet. Okay. Multiply straight across, you're going to get 12 over 720. And again, if you fully simplify with the calculator, which we're technically supposed to in this problem, you get 160. All right, last problem. Probability of S and then another S. We're restarting with our numbers. We have 10 marbles in the jar. Only 1 of them is S. Hopefully some of you can see where this is going by now. And then we're going to pick another one out. Remember, marbles are not replaced, so I have 9 marbles left. Now, since I'm trying to pick another S, I have to take into account I had 1, and I picked it out the first time. So when I go to pick another S out, Well, I don't have any left. I've got 0. So, if I multiply straight across, 1 times 0 is 0. 10 times 9 is 90. Hopefully you're already thinking, well, that's not possible. Right. So your probability is just 0. You can leave this as 0 over 90. It's technically correct, but anytime you have 0 over something, it's just 0. And remember, if you're not sure how that works out, you always put it in your calculator. 0. It's not possible. You can't pull 2 striped marbles out of a jar when I've only got 1 in there and I can't put it back. So, 0. Alright, number 13, the table problems. The thing to keep an eye on here, we do have our total columns, so that's very helpful. A, how many students participated in this survey? So just taking a general look at the table, we now know based on the question that this was a survey given to students, and they were asked whether they took biology or not, and whether they took art or not. Now, how many participated in the survey? That's the whole table, so you want the big total. It's in the bottom right corner. If you've got those total columns, that's where it'll be. So 20 students participated. How many students are taking biology and art? So I want the students who are taking both of them. If I choose any other category, they're taking one but not the other. Or neither in this case. So biology and art, that's 2 of them. Now make sure you're paying close attention. I'm not being asked for probability yet, so I'm just asking for specific groups and to pick out those numbers. So I'm not creating any fractions right now. How many students are not taking art? So I find the not art column, and it doesn't matter if they're taking bio or not. That was not the question. It's just how many are not taking art at all. 15. D, of the students surveyed, what is the probability the student is taking art? So remember, when you see the phrase of the or given, you need to circle it because that's where your total is coming from. Of the students surveyed. Well, that's the whole table of everyone in the table. So we're still using that big total 20 here. What is the probability the student is taking art? So remember, what is the probability? You're going to need a fraction. So we have our total on bottom. That's 20. We just found that. Of these 20 students, what is the probability that they're taking art? So of everyone, how many are taking art? 5 are taking art. 5 out of 20. And then again, if you reduce this, it is 1/4. All right. Of the students that are taking art, pause, circle that. That's your total. You see of the, or in the next problem, we're going to have a given, same thing. Of the students taking art. So we're saying from this category only. So our total is how many students are taking art first. Of these 5 students that are taking art. That's all we're considering. What is the probability they are not taking biology? So we have our total on bottom. Of those 5 students, what is the probability they are not taking biology? So, of our total of 5, how many are not biology? 3. 3/5. Can't reduce that, so that's our answer. F. Given that a student is taking biology, pause, circle that, that's your total. Given that a student is taking biology, so we're only looking at the biology students here. How many are taking biology? 9. of these 9 students, what is the probability that the student is not taking art? So we have not art over the total. 9 of them, that's our total. We've already discovered that. Of those 9 biology students, how many are not taking art? 9 biology, 7 of them are not taking art. Can't reduce that. Last one. Given that a student is taking art, pause. Notice I'm always pausing at that comma. Given that a student is taking art, that means we are looking at only the art students. So again, there are only 5 art students. So of these 5 art students, what is the probability that the student is taking biology? So we want those who are taking bio out of that total. Out of these 5 students, how many are taking biology? Let's look. 5 art students, 2 of them are in biology. So 2 out of 5. And that's it. So on those, just make sure you take your time. Take a minute. They're not that hard, but obviously if you look at the wrong detail here, or you misread the problem, you're going to get a completely different answer, and that matters. It's going to make a difference. Okay, functions, linear, exponential, and quadratic. Okay, so this is where we look for patterns in the table. And remember, we are only looking at the y values here. Only the y's. And I'm going to do that in every single table. So I'm just going to look at my numbers first. 14, 10, 6, 2, negative 2, negative 6, negative 10. So my numbers are going down. I have no repeats, so this is not quadratic. Now let me see how my numbers are going down. Are they going down by simple subtraction or by division? 14 to 10, well that's minus 3. Or minus 4, excuse me. And then 10 to 6, that's also minus 4. 6 to 2, that's minus 4. I'm 3 patterns in by now, and it keeps repeating. So I feel pretty confident that I am subtracting 3 on all of these. Oh my goodness, 4. I don't know why I've got minus 3 in my head, but I do. Forgive me. Okay. 14 minus 4 is 10. 10 minus 4 is 6. 6 minus 4 is 2. 2 minus 4 is negative 2. Negative 2 minus 4 is negative 6. And minus another 4, we are at negative 10. This pattern holds up. Now remember, when you add or subtract, that means you have linear. A linear function. B, again, y values only. Negative 18, negative 6, negative 2, 0, 2, 6, 18. So I don't have any repeating numbers, so it's not quadratic. Let's try to find a pattern. Negative 18 to negative 6, and I'm actually going to switch to pencil here because I'm going to end up erasing. But just to demonstrate the point, let's say you're sitting on test day, you're trying to figure out what's going on here. If I were to subtract, or actually this would be addition since we're working with negatives, this would be plus 12. Again, if you don't believe me, we can verify that. Negative 18 plus 12. Hang on, let me try that again. Negative 18 plus 12. There we go. That gives me negative 6, so that is the pattern. And then to get from negative 6 up to negative 2, we add 4. So clearly this is not linear. We can get that off the table here. And if you need to, you can make a list and go through your options. So we got linear, quadratic, and then exponential. It's clearly not linear. That did not work. So let's try exponential. Remember, exponential works with division. Now, this one's tricky, so be very careful. Negative 18 to negative 6. Well, we can divide by 3 to get there. We can. Again, you don't believe me? Just type it in a calculator. Divided by 3. I'm going to delete that extra number. And then I can divide negative 6 by 3, and I get negative 2. Now, don't stop here, because after this, the pattern breaks. This is why you really want to check most of the table, if not the whole table. Negative 2 divided by 3 is not 0. So it's not exponential. Now, I know I've already verbally ruled out quadratic, but I will have some students that will say quadratic, because you're like, oh, look, these are both a 2, these are both a 6, these are both an 18. No, the signs are different, and yes, that matters. The numbers have to be exactly the same. So this does not mirror at all. The numbers have to be the same sign. Since they're different signs, this is not quadratic. When I say numbers repeat, they have to completely repeat. So we have exhausted all 3 options. This is none. See? And again, you can always just make this list and go through them one by one. Y values only. 1/9, 1/3, 1, 3, 9, 27, 81. So right off the bat, we have no repeating numbers, so this is not quadratic. Now you can play with both of these, but I think your gut should tell you which one it's more likely going to be, and that's exponential. 1, 3, 9, 27, 81. These numbers get big pretty quickly. There's no way you can do that with simple addition. And especially with how large the gaps get. 1 and 3 are pretty close together, but then 27 and 81 are pretty far apart. Again, if we were adding the same number, this wouldn't happen. So let's go ahead and go with exponential. Now, fractions are not your thing. A lot of people feel that way. Go to the whole numbers and work with those. So 1 to 3, that's times 3. 1 times 3 is 3. So let's repeat that. 3 times 3 is 9. 9 times 3 is 27. And then you can verify this with a calculator. 27 times 3 is, in fact, 81. And then this does work with the fractions as well. 1/9 times 3 is 1/3, times 3 is 1. So, since we were able to multiply for the pattern, that means this is exponential. D. Once again, y values only. "30, 20, 12, 6, 2, 0, 0. This one's weird. It should automatically just you just know, like something's off about this one. We do have a repeating number, so typically that would mean quadratic, but problem. It's not mirrored at all. It's just repeating the same number twice in a row. When I say repeating, you would want a 2 here, for instance. It would be 2 and 2, and then 6 and 6. That's not happening here. So, be careful with that. That does not necessarily mean quadratic. We do not have a mirrored effect happening here. So, this is not quadratic. Again, quadratic would look like B if all of these were positive. That's what quadratic would look like. We definitely don't have that here in D. That, if it's not quadratic here, since the zeros repeat, pretty much we can say that it's none. But just to really, exhaust our other options. So again, I'll make my list. It's not quadratic. We've already ruled that out. Linear, if we try to go down in pattern, 30 to 20, that's going to be minus 10. And then if I repeat that, 20 minus 10 is not 12. That's minus 8. We can't change the number. It has to be the same number the whole time. So linear is out. Exponential. Whatever number you divide 30 by to get to 20, it's not going to be a nice number, and we're not going to do that to you. And it's certainly a different number to get from 20 to 12. And then on top of that, I know for a fact 12 to 6 is divided by 2. And then 6 to 2, that's divided by 3. So there you go. But the first two would be fractions of some kind. So already I've hit a different number. So just to further confirm, this is none. But again, when you have a repeat digit like we do here, we have those 2 zeros. If you don't have a mirror effect happening, it's none. Because the only function that repeats is the quadratic. The other two do not. And I repeat, do not. Do not repeat values in the table. Only quadratic does. And if it's not a perfect mirror, which we didn't have on this page at all, it's none. So it's a pretty easy one to roll out. 15. These look difficult. Don't overcomplicate them. For each equation below, identify if it is linear, quadratic, or exponential. I'm going to write their general equation forms over here. So, if it's linear, y equals mx plus b, you've seen it a million times. Quadratic, y equals ax squared plus bx plus c. And then exponential, this is the one you are least familiar with. Y equals a times b to the x. So what you're looking for in each of these. Y equals mx plus b, you're looking for just a plain x. For quadratic, the dead giveaway is the 2, that exponent of 2. And then the exponential, the dead giveaway, is the exponent of x. So if you can't tell which equation you have, process of eliminate your way to get to the correct answer. So, A, 3x minus 4y equals 12. It doesn't look exactly like one of these forms because y is not by itself. But, one, you should still recognize it with as much experience as you have with this. But if you don't, let's rule out the other options. Linear, maybe. Quadratic, it has to have x squared. This does not have x squared in it. It's just a plain x. Once again, plain x should be your indicator. This is linear, but if not, you don't have an x squared, so it's not quadratic. And then exponential, x is literally the exponent. We don't have that here either, so the only option it could be is linear. So if you're not sure, use process of elimination. B, 4 to the 2x. Now, I know it's 2x. Don't let that trip you. X is the exponent. This is exponential. Quadratic is when it's 2 and only 2. We have 2x. This is not quadratic. C, y equals 0.5x squared minus 2x plus 1. We have that x squared we need. This is quadratic. Again, you don't have to think too much about these. D, y equals 3x minus 6. You should recognize that as y equals mx plus b. This is linear. Number 16, label each graph pictured as A, linear, B, exponential, or C, quadratic. So I'm going to go through and label these lines really quickly. Linear, remember linear is for line. So you want the straight line here. Next, the exponential. That's the one that gets very big very quickly. And lastly, the quadratic. That's going to be the last option here. Plus, you should be familiar enough with the quadratic. It's a parabola. It's that U-shaped curve. So those are my 3 functions. Now, for this problem, it is highly recommended that you highlight. So you pick 3 different colors. The colors do not matter. Just make sure they are different enough that they are pretty, they stand out. They stand out quite a bit on the graph. So those are my 3 colors. I've got a dark blue, a light green, and a light orange. Okay, so I'm going to make my linear the orange. And then I'll go green for the exponential. And then blue for my quadratic. Okay, now they kind of stand out a little bit more. All right, which function shows a constant rate of change in its y values? Remember, rate of change just means slope. Which function shows a constant slope? And remember, constant just means the same. So which function shows the same slope in its y values? So really, if I look at the 3, linear is going down the entire time. Quadratic goes up and then it goes down. This should obviously not be the answer because it literally changes. So it's not the same slope the whole time. Exponential does go up the entire time, but notice it changes in its steepness. Linear does not change in its steepness. It is the same the whole time. So linear is the answer. And by the way, the answer to this specific question will always be linear because that's how linear functions behave. The other 2 do not behave this way. So I wouldn't even need a graph, honestly, to answer this question. Okay. B. Which function is the smallest between 0 and 1? So this is one where you will want to mark that space on the graph. So I'm going to do that in pencil. So between 0 and 1. So 0 is right here. I'm just going to, in pencil, make a darkened line up the 0. And then 1, be careful here with where this is at. 0, 2, so right in the middle here is going to be my 1. Okay, so I've got 0 and 1 there. Now, I want to look in between this space, so I'm going to shade it lightly so I can still see everything else I've written. Now, the question is, which function is the smallest between 0 and 1? Basically, which function is the lowest is the best way to look. So I'll write that down. Lowest. So if we look just in this space, we can see that at the bottom here we have the green function, which is my exponential. Here, quadratic and linear are kind of fighting for who's better, who's going to be higher up than the other. And so they kind of change positions throughout. But good thing is we don't really have to look deeply into that because exponential is clearly the lowest here. So, exponential. Which function is consistently, you could also say always, increasing? Well, linear is going down the entire time, so that wouldn't be it. Quadratic goes up and then down, so it's not always increasing. It's increasing for half of it, but it's not increasing the whole time. Exponential is the only one increasing for the entire graph. So once again, exponential. D, list the functions in order from smallest to biggest when x equals 3. So, when you see, I'm going to do this in pen. We got smallest to biggest, pay attention to that order, and then when x equals 3. So, let's look at x equals 3. So, find 3 on the graph. We've got 0, 2, 4. 3 is going to be in the middle. Remember, that's just a vertical line through that number on the axis. So there's the 3. So I'm going to draw a vertical line through here. You can do this in whatever color you like. And I'm kind of thinking, actually I do have black. I'm going to do black. Just so it's not blue, because I've already got blue on my graph. If you want to do this in pencil, be my guest. Okay. So I'm now looking along that black line. Now, we want smallest to biggest. So you're going to start at the bottom and work your way up this line. And then every time you hit a function, you're going to write it down. So I'm starting down here. First function I run into is orange. So the orange function is linear. So linear goes first. So bottom, linear. Next function I hit is the blue one, which is the quadratic. Meaning my last one should be exponential. I'll check for it. Okay. Linear, quadratic, last one is exponential. And if you need to mark those points as you go, just to make them stand out even further, you can do that. So those are the 3 places where they hit, and this is going to be from smallest to largest, because obviously it's going to get bigger as we go up. Linear, quadratic, exponential. All right. Last one for this graph. List the functions in order from smallest to biggest. So once again, same order. When x equals -3. Now this one appears to be off the graph, but it is just barely included. This is -2. The next number over would, in fact, be -3. So we'll say it's right there. We're going to do the same thing. X equals -3. So I'm going to draw that nice vertical line through the number. Now, once again, you have to use all of the functions in your answer. And just because you don't see the function doesn't mean it's not there. So when we're going off the graph, make sure all of your functions, you can still see where they would hit this line. So I'm going to extend all of these just a tad bit. Exponential I don't really need to extend, but just for the sake of this I will. It's going to keep going like that. So it's going to hit there. Linear probably doesn't need extended, but I'm going to anyway. Something like that. So it's going to hit right up there. Now I'm missing one. Again, you can't leave it out of the order. You're going to have to use your imagination a bit here. So I'm going to extend this blue which it does not have to be perfect. You can clearly see where the graph is going. So that's what really matters. So it's going to hit somewhere all the way down there. So now that I've found where all three graphs hit this line, I can easily answer this question. Bottom to top, the first function I hit is that quadratic. Quadratic, go up. The next one I hit is the exponential. So bottom to top, quadratic, exponential, linear must be my last one, and it is. It's at the top. There is my order. So remember, 17, this problem does not take a long, it does take a minute, I guess, if you're marking everything. But if you mark everything, you color code, you pay attention to what they're asking you, it is not a difficult problem. That's what I meant to say. All right, back page. This will probably be the shortest page of the study guide, so I'm basically done. Using the scatter plots below, A, match the following correlations to their graphs. Positive, negative, or no correlation. And then don't forget about B when you're done. Which graph has the strongest correlation? So first I'm going to go through and just label what type of correlation we have here. And remember, positive and negative correlation look like positive and negative slope. So those are very easy to tell. And then no correlation is when it just looks like a random pattern, a random array of dots. Okay. A clearly goes up. It's a nice upward trend. This is positive. B, it just looks like a mess. This is no correlation. C, it's going downward very nicely. This is negative. D, it's going down nicely. This is also negative. Okay. E, it's going up nicely. This is positive. And F, this is going down nicely. This is negative. So we've labeled all of the correlations. Now take a good look. Which one would you say is the strongest correlation? If you don't have an answer yet, remember a strong correlation is going to form a neat line. There's one example that is pretty obvious here, and it is F. Notice it is almost a perfect line. This is what you would like your data to look like in a perfect scenario. This would be the ideal graph to have. So which graph has the strongest correlation? Graph F. The others, besides the no correlation, the other four, all look to have a very similar, strong, I wouldn't say it's strong or weak, it's kind of in the middle type of correlation, and then this one's very strong here. All right, number 19. Using the scatter plot below, select the true statement. So first, just look at your graph and just kind of gather what's going on here. On the x-axis, we have TV time, hours per night. So this is how much time these people spent watching TV. 1, 2, 3, or 4 hours, or somewhere in between. And then their test score. So I know what the problem's about, but if you had to just kind of think about this for a moment. Like, this is how much their TV time is affecting their test score. As you can imagine, the more TV you watch, the lower your test score is going to be in general. So let's see which ones correctly states this. A, the graph shows no correlation between watching TV at night and the results of student test scores. I would disagree with that. There's a clear pattern here. B, the graph shows that student test scores will increase with more student TV viewing at night. I disagree. One, that logically makes no sense, and two, the graph says differently. You watch more TV, you're not going to do as well on that test. C, the graph shows that student test scores will decrease with more student TV viewing at night. This is a good way to put what the graph is saying. For good measure, I'll read the last one just to make sure it makes no sense. The graph shows that the TV ratings of a series called Test Scores is decreasing at night. 1, that's kind of a funny spin on the graph, but 2, no. And also, I guess it kind of makes sense for the y-axis, but really it doesn't. That's someone who just completely does not understand what the graph is saying at all. So no, C is correct. 20. Using the same scatter plot in 19, approximately what was the student's test score after watching A, 2 hours of TV per night, and then B, 4 hours. So, 2 hours, let's follow it up. There's 1 point, it's right there. Now, obviously, answers are going to vary, but make sure that the answers make sense. So, let's look at the y-axis. This is just above the 20, and then the next line up is 25. So, obviously, it's between 20 and 25. It's closer to 20. So, you could put about 20. Now, if I was going to, like, put money down on an answer, like, this is my bet. This is what this number is. If I wanted to put a solid number to it, I would confidently say 21 or 22. I feel like 22 would be, like, my confident answer. Now, again, obviously, we might disagree on what that dot represents. We can agree on a few things. 1, it's clearly not 25. And it's probably not clearly 20 either. It is somewhere between 20 and 25. I think we can all agree on that. So pick a number between those two, and you should be fine. Obviously closer to 20 if we want to get more accurate here. 4 hours. Find the dot. Okay, we got 10, and then the next line up is 15. So, clearly we can see that this test score is going to be between 10 and 15, close to 15, but I'd say under 15. So, I think we can all agree it's between 10 and 15. Now, they want us to give a test score. So, again, if I were to lay money, what I think the answer is, I would confidently put, if you're asking me, 13. That would be my confident answer. Now, obviously, there's going to be a little wiggle room for answers like these. So if you put a slightly different number than me, but I can be like, yeah, that makes sense. You get the point. Now, don't put something outlandish. This is obviously not 15. It's obviously not anything higher than 15. So make sure you stay within the range that I just gave you here. Again, pretend you are putting money on it and you want to win this bet. What number would you choose? Come at it with that thinking. Again, it's not going to be an exact answer because we're kind of just making an educated guess here. 21. What correlation can you make according to the graph? So, we're just looking at the general trend here, what's happening to the points. This has a decently strong negative correlation. And that's it. That's the entire study guide. I hope this video was helpful. If you have any additional questions, feel free to reach out to me via email or come see me in person. Otherwise, I hope you have an awesome day. Bye.